All right, here we go. So, circuits at the very heart, fundamental. Kirchhoff's junction and loop rules. Okay. So, I see that. Okay, so 5 amps are going in. 5 amps are coming out. Okay. So, junction rule says current in equals current out. Oops. So this is current 1 is equal to the sum of current 2 and 3. All right, so this is a conservation of charge.
Okay, Smiley, I'm ready to learn.
Good. So students last year, after the AP test, said that the multiple choice was highly conceptual.
Let's go.
And here's what I think they're doing. They're making the switch from the old traditional way of APC to the new reformed, like, which is gonna look more like AP1. Okay. So having a good conceptual understanding will go a long way. Okay. Okay. So that's Kirchhoff's junction rule, loop rule. Says the voltage gain equals the sum of the voltage drops. This is the chutes and ladders analogy, where if you have like a 12-volt gain,
It applies over any loop, not just ones in wires.
that is true.
I hate.
Okay, so you have like a 4-volt drop, and then like a 6-volt drop. Yes.
Nice. Good one, Bradley.
Okay.
Sam's had too much excitement today.
Uh,
Got him.
okay.
Getting that vitamin C.
So, yeah. This is conservation of energy, because what electric potential looks at is how much energy there is for a certain amount of charge, how much energy is being delivered per electron is a very conceptual way to look at it. Okay, rather than per coulomb. That's mathematically, per coulomb is how it kind of works out, but per electron, that's kind of how I think, how much energy each electron is contributing. Okay.
In terms of electron volts.
Yes. Okay. Good with that. All right. So, in terms of, I think I've showed you this slide already. So resistance. So in series, the current is the same due to junction rule. There are no junctions in series, and so the current in has to equal current out at every point in time. If you have a capacitor, the charge is the same, and this is a direct application of Kirchhoff's loop rule around a series circuit. The voltage gain equals the sum of the voltage drops in parallel, because each resistor is hooked up to its own loop. Voltage gain equals the sum of the voltage drops. This is 12 volts here, there's 12 volts here, and 12 volts here because it's on the same loop. This is a consequence of junction rule, because at this junction, what's going in has to go out, and as you add more of those, there has to be more current to supply that, so current adds up. Okay. Power. So Ohm's law, power. He's ready to learn.
I'm ready to learn. I'm ready to learn how to tie my shoes.
Because I just did because it's parallel, so the voltage is the same for all of them, right? So I did 12, and then I set it equal to whatever the resistance was, and I did the resistance I got from the problem earlier, which was right. So I don't know how I got that one wrong. So that's what I did over here.
Don't round this. Like,
Don't round what? Wait, what did I round?
I don't know. Like, it seems like a good strategy. I just don't know what you did wrong. So don't round is my suggestion. All right. Correct answer is
C.
Good job. Yep. Okay. All right. So the easiest way to do this, I mean, there's several different ways you can do it. Add up your total resistance. It's 12 divided by 24 volts, or you get 2 amps. And so 2 amps is the total current times 24 volts. Okay, you could find the power dissipated by each one of those and then add them up is another way you could do that. You got options. Tell your neighbor. Anything different?
Wait, maybe
Resistance decreases.
This is one of the things you have to work around when you're building a custom boost converter.
Yes. When I build, I hate when I have to get there.
Okay, correct answer is?
Hey. Uh-oh.
Correct answer is on decreases 1. This is gonna go increases. Current goes up. Okay. So what about the voltage drop across R1?
It's gonna decrease because it's so. Wait, I'm confused.
Tell your neighbor why.
I'm confused. Okay.
Voltage equals current times resistance. So if the resistance goes down, the voltage goes down.
Okay, correct answer is decreases. The voltage gain is determined by the battery power supply. That has not changed. So it still has the same ladder. We're just changing. We're changing the length of this. So we said we increased the voltage drop across this one because the current got higher. Therefore, this has to get smaller. Energy in has to equal energy out. Good. This should be like a comfort zone.
I don't know it. Resistance.
Resistance to Sam wanted to learn.
Resistance to power.
Tell your neighbor.
Okay.
Tell them why.
Current is equal to voltage over resistance. Power is equal to voltage, or is equal to current times voltage. So power is equal to voltage over voltage squared over resistance.
Okay, the current is going to be the same for, the current's going to be the same for all of them. Power is.
Let's do it. YMCA.
Correct answer is A. Okay. The voltage is the same across each one of those. It's in parallel. So what's going to have the most power is the one that has the most current. The one that has the most current is the one that has the least resistance. Okay.
Oh. Thank you for reminding me. Sorry.
On.
Oh,
I like that. I like that one. Sugar one.
Tell your neighbor.
I combined these two for parallel.
Good.
And I got that, right? And then I combined these two. I wasn't sure if I should do that or not, but I did it because I didn't know what else to do.
Okay. So here.
No, because 5 is the
This is your
junction
battery.
all
You pull this one
5
out.
is the same as
What would
before.
happen?
That one you got, right?
Right.
Seriously.
5, 4, 3, 1, 2. Final answer C.
Correct answer is
C. C.
C is correct.
C for correct.
Okay. Current going in. This one has most current because it has least resistance. But then 4 is a combination of 2 and 3. 5 is a combination of 1 and 4.
Wow.
Because of junction rule.
Wow. What's your function? Oh. Smiley, you got an apple refill.
Did.
Oh, from the FFA. Future followers of apples. Sure, true.
Tell your neighbor.
Hey.
Tell them why.
You have more than What do you
Okay, so you're going to, so what you do is you add the new wire connecting it, don't put a resistor on there. Obviously, that's going to increase the total current that goes through. Now you put a resistor on that new wire. So
Yeah.
while you're loading the, so you're loading the kind of current that goes
Okay.
through the wire.
Check your lanes.
Correct answer is.
Check out lanes at Walmart.
There it is. Increases. We're opening new checkout lanes at Walmart. We're popping more holes in a water tower. No, never.
But the checkout lane double. Checkout lane. The water hole makes sense too. Smiling initiative before that.
Okay, Brad. If you take a water bottle and you poke holes in it, there's still going to be water coming out of the hole.
No, this is a consequence of the previous one. I mean, math.
No, that's
You're
not
right.
how
I
it
mean,
More
when you're
checkout,
building
double
it
Walmart.
conceptually,
More checkout,
this is
more money.
do this first mathematical. Mathematically, it would. Yes.
More apples at the
Correct answer is
More apples now.
C.
Uh-oh. Oh,
Okay.
I had D for D. Oh, yeah.
Good with that?
Yes.
Just the 1 over R thing. Okay.
Wow.
All the time I do crossword puzzles, and the question is like, what is the unit of resistance? That's always wrong.
Yeah. Good stuff.
So that's the only time that this has ever benefited me in real life.
Oh, Cora. There'll be a time. I think there'll be a time.
Are you sure? 1 over a million.
Okay. Tell your neighbor.
1 over A. Oh yeah, A. 1 over 1 plus.
Okay. You could do it.
1 over 1 plus 1 over a million. A little less. A million.
You could. Okay, so you could plug this into your calculator. Remember to find the reciprocal because you're equal to 1 over R. But conceptually, your total resistance in parallel is always going to be less than the least resistor.
Less than the least resistor. Oh, because they can all go through there, but like one goes through
Yep.
there.
Yeah.
Okay.
10,000 over 10,001.
All right, give that one a shot.
So for this one, it's asking for the current, and I solved for the total resistance, and then I did the voltage, which was 9, and I got the current, but it's series, so I just put the current that I got, but it's wrong. So I don't know why it's wrong.
This is a Walmart like that. Yeah, you have to go through this one to get to the cashier.
Yeah,
See?
okay.
R1
So
is the
AB.
government taking your taxes. They take one apple and then they skip.
Who buys
These are-
TVs?
these are
That seems like a waste of money. You can just buy monitors.
Go like this.
So there's like
TV
a
are just big
lot
monitors.
Yeah. Yeah, that's what AB is saying.
and then if I got the answer for the total there, then it
I don't know. I'm
Few more steps.
pretty sure my son's monitor is pretty cheap.
Yeah, probably.
Those came from these two wired how?
I am not that
Yep, so what's it say?
Oh, so it's not the same because
No, I don't
Can we have time so I can use the
Isaac.
bathroom?
Do you like look at the monitor like
Hey
this?
guys, can we stop class so I can go do something
No.
else?
Okay.
That's not how that works.
Half time. You can have time.
Oh, we don't.
Fine, I'll hold it. I suffer.
It's finally like a halftime show.
What?
It's a halftime show.
Just don't
All right.
water before
So
You want to know
what?
I have to say about that, Smiley?
Nope. What do we say?
C.
Walmart.
C.
Okay. So
I'm
we
going to the
know.
bathroom.
Okay.
Is the longer one negative or positive?
Oh, battery terminal. Positive. The longer one's positive. You just need to frame it a little better. The longer resistor is positive.
negative resistance.
Okay, so when you shut this and the switches close, the total resistance goes up or down? Down, because these are in parallel. So the total current goes up. Okay, so there's more current going through this guy. The resistance on this one stayed the same. Total current goes up, so voltage drop across that will also go up.
So Walmart lens. We add another Walmart. How much are people going to want to go through? No. But if you add more Walmart lens, more people want to check out. That's not.
No, you have it backwards.
That's
How good is the
And if the voltage goes up, that's like having a sale.
no.
No, stop with your Walmart lane analogy. It does more harm than good.
There's my making Walmart lane jokes. I did actually do that.
Can our homework be to go to Walmart?
No.
No more reading.
No,
Walmart
I'm
quiz.
not able to do my homework. It would be intentionally to not do it. I'm actually not able to do it.
All right,
What is wrong with Walmart?
have a conversation.
Because
Tell them why you think so.
the voltage, so we already know R1 is going to increase because of the last thing. So then the rest of the voltage for the other parts has to decrease, and it's all the same voltage.
Figure it out.
I don't know why it's Sunday.
However, I
Like that.
Okay, I'm wrong. You have more people can run the Walmart than R1. So you can use.
Well, remember this. The voltage across the battery is not changing.
It's the same as this one, right?
Okay, correct answer is?
C. I'm confident.
Correct answer is B.
Let's go.
Decreases. This is the same scenario as this. I just try to make it different. Just to mess with you. But conceptually, it's the same idea. And it's the same conversation, same type of conversation as what you had here. Okay? So the loop rule says the voltage gain hasn't changed because we haven't changed the power supply. We increase the voltage drop across this guy. Therefore, we have to decrease the voltage drop across this branch, like whatever's back here. And they're independent, they're in parallel, so the voltage drop across this one is equal to the voltage drop across this one. Good with that?
The question is actually answerable.
Riley put an impossible question on the
I didn't read the assume that all resistors are equal. I'm like, we don't know the various resistances of the resistors.
Isaac, that's how I feel when I pick the master. Just give up.
Have a conversation.
Wait, heck. Oh, it is. It is D.
Have a conversation with an explanation.
Okay. So you have two Walmarts.
This is one of the easy ones, but I don't think I know what it is. Because the ones with like the numbers and stuff.
Okay, so find the total power.
Okay, so just most by
Okay, so that's your maximum power. Each light bulb contributes 65 watts. Power just adds up.
Oh, so just how many of that can go into it? Do I do 2.7?
Can you have 2.7 light bulbs?
I don't know, 2 light bulbs?
You have less room for R3 and 4.
So it's a 2 to 1 ratio. So it's gonna get R5 is gonna get 2/3.
But R3 and R4 are the same. Because.
Yeah, they're the same resistance.
Okay.
Oh wait, yeah.
Right, just be able to draw it out.
Okay,
I am able to
Brad,
draw
we're
it out.
drawing
Why
it
am I
out.
complaining?
Brad, what are we drawing out?
You draw it out for me. Sorry.
So it's gonna be exciting.
Okay, ready?
Yeah.
Okay, so there's a certain amount of current, we'll just say 2 amps just to keep things simple, coming out of here. At this point, that 2 amps splits equally because they have equal resistance. 1 amp's going this way, 1 amp's going this way. It comes back together, and in this wire there's 2 amps. Okay, because of the junction rule. When it hits here, there's more resistance this way, therefore less current goes this way, more current goes this way, making these numbers up. Let's say you get 1.5 goes this way and 0.5 goes this way. That makes sense?
Yeah.
Okay, so correct answer is R5. Okay.
All right.
Daniel can say.
Daniel can skip school. Bro, he's Duncan as we speak.
Brad missed that entire joke.
I was sitting there like, what the heck is going on?
Brad, they made it this movie called Chase Hands On. It's about this Asian guy who's trying to
And
play
he's been
basketball. Well, no, like, that's the question is if he can. Did I mention his name is Chase?
That's the climax of the movie. He said dunk.
And people don't think he can dunk.
Yeah. I'm cutting the most I do that day.
Yeah, I just don't know what that does that.
That just means that R7 isn't like it's not part of it.
No. I gotta put this in the
Racist.
Oh my god, bro.
Well, to be fair, you didn't hear DZ's response.
True. I can't say it.
I can't question.
It's too good.
Oh, wait, that's true.
It is a good question. Probably should.
We're gonna take a guess.
Uh-oh. My answer is on the board.
Mine too. Well, it's F then.
Oh wait, hold on.
We all know it's never F.
Mine will be in 1 second.
Did you forget?
Got it.
Spelled resistor wrong.
Oh. Hey, he's not dissipating right, alright? Let's give him credit.
The
Wait, dissipating has two S's?
It's the register. Register. The checkout lane.
All right.
D.
Tell your neighbor. Tell them how you got there.
Reasoning, I did the math.
I guess.
They have to have the same voltage, so the ratio of resistance to current in one side of it has to be equal to the other. So then you find the current and you add them, and then you find the power.
Sam's magic or chain
Wait,
magic?
that's good.
If the switch is closed, is it still the same wavelength?
No. You have to include it.
Or wait. It doesn't change though, it's just like a parallel in between those two.
Yeah.
Or just add it in.
7 and 4.
You know, 45.
Okay. What do you say? D. Okay. Real fast. These two are in parallel, so you know the voltage is the same. You can figure out the voltage across this by taking your resistance times your current. You get 20 volts. There's 20 volts across this one, meaning that there is one amp through this one. So there's 2 amps here and 1 amp here. Therefore, junction rule says there must be 3 amps here. And you can either go that route or you can do the shortcut and say power is equal to I squared R. And so you get 45. Okay. Good there? Here's the other shortcut. Okay. That's just substitution of those two.
My back is killing me right now. I have no idea why.
Okay.
I think I know why.
I'm just gonna lay that.
Okay, that's fine. All right.
That's not what.
All right.
The original circuit.
This is your quality or not quality control. This is your control group. Okay. Remember this lab quiz?
Yeah.
Spent 3 days on this.
Oh yeah. Hold up.
I don't remember this lab. We can math quickly. They're equal resistors, right?
No, not necessarily.
Mine is DC resistor. Not that it matters.
It was, yes.
It does, because if it were just a wire has resistance.
Yes.
It wouldn't be brighter at all.
No, actually, it would be a lot brighter if it were just a wire.
Like you short circuit that separate. So I guess it doesn't matter.
Then it's, oh, yeah, true, because the wire technically has some resistance. It's a very small resistor.
Oh wait.
If AB was a brick, then it would matter.
I'm pretty sure if BC were a brick, not A.
Can you write down the-
If you were pregnant,
Can you write down the other shortcuts?
Sure.
Power.
Oh.
B squared over R.
Damn.
Your character's consistent.
That's true. Unless you see me in my English.
All right, thumbs up when you have a guess. Have a conversation.
A, B, what?
So the resistance
DC was
less
2D.
current, so the voltage has to go now too. Both voltage and current went up.
Ooh, that's a good point.
Hang on just a second.
But I want it to be A.
I also want it to be a.
We all.
I want to get a 6 on the AP test.
Probably not.
Think about it in the extreme case where it's barely a resistor, just a wire. A wire has some
This is the voltage across the right path doesn't change. Because according to the loop, the voltage
Included in it, but I don't know. I got to this point because I have 7 here, 3 here, and that there, and that. And I added to it, and because I figured like that would be series, and then that would obviously.
Pull this one out.
I would still go.
Everything is still good. Yeah, if you pull 7 out. So
Those two would stop at that.
So this one and this one.
Oh wait, no, because that's okay. Wait, yeah. Sure, these two,
Parallel.
and then you solve
And then,
series.
and then you do series. Uh-huh.
Okay.
Okay.
No, but it's in parallel. Right, but why would the distribution?
But it's in.
No, the
Like
distribution
what
between
is
those.
it parallel, which means
No, the distribution between those.
Yeah,
would
but the
not
distribution across DE versus FG isn't gonna change.
Yeah,
You know,
because
the thing I'm thinking about is take the case where.
before they had different current, but now they have to have the same current, so the voltage has to be different.
I disagree with that.
No, liberal would violate that. What I
Just tell us the answer.
what I
Smiley,
think.
what's the answer? And then we can debate it.
Okay. So here's our original.
Just tell us the answer.
Okay. BC is in parallel with DE and GF. Okay. When you take this away, the total current coming from the power supply decreases. True. But the loop rule says, let's say this is 10 volts. There's a 10 volt drop across this, and just to keep things simple, we'll say a 5 volt drop across this and a 5 volt drop across this if they were identical. Okay. When we take this away, you still have the same voltage drop across there. Where the current decreased is the amount of current that was running through this wire here.
And also the lower.
Once it hits this, it's the same as this point here.
So you're telling me I haven't gotten any smarter since last year.
This was the same.
Correct answer is C, the same.
L. Bradley.
Okay, I'm confused because let's say because a wire has some resistance, so it's technically.
Okay. So we are ignoring any resistance in the wire.
Oh, because they're still like.
That's not what I'm talking about. I'm saying so we're gonna call CE a 2 ohm resistor. We're going to ignore TF because it doesn't matter. And we're going to put a 1/10,000th milliohm resistor at BC. So for all they're removing.
I just said that the voltage.
Or whatever would be equivalent to a real world wire.
Okay, so here are a couple things. I don't know if I get to this. Let's say we have no resistance here, and it's just a wire. Okay. In reality, that's going to cause this light bulb to turn off. Okay, because this is a short circuit. Ideally.
Is that what short circuiting is?
Yep. Ideally, this wouldn't be affected because the power supply could have there's the same voltage drop across here, but the reality is that a power supply can't supply an infinite amount of current, and so you get this whole phrase where electricity takes the path of least resistance. I kind of cringe at that because conceptually that's not valid. In reality, sometimes that's true, but it's not all. It's not like here's where the pitfalls lie. Like, oh look, this path is more resistance, therefore all the current goes through this. Electricity takes the path of least resistance. Not true. Okay. Um, in an ideal world, if this is just a wire, it wouldn't affect this, but in reality it does because this can't supply an infinite amount of current.
Okay, I wasn't going
So-
to look at that because I was going to just randomly account for the resistance of the wire in there.
so-
to make it something like
so
20,000 million.
When, just like in the default is ignore air resistance, in mechanics, the default is ignore resistance in wires. Okay. So is everybody good with does not change? It's in parallel.
Okay, yes. If we're ignoring
Okay.
resistance in wires, yes.
So, shoot. That is hilarious. Dogs. That was not a good timing on that explanation.
Yeah, that was really bad.
Let's pretend that this is just removed and there's a wire.
But hold up. So the answer is C
No, it's
to
not.
this question. But the voltage.
Which is the same net resistance.
But the resistance.
Net resistance.
Shit.
You've added a third second.
All this does is in essence make this just a wire. That's all that's trying to say. You remove that light bulb resistor and place just a wire in there.
Yeah, that was really bad timing with your explanation.
It was.
Sorry.
It's all good. We recovered, I think.
I have not.
Yes, go guys.
Tell your neighbor.
Okay.
Tell them why.
Net resistance goes down, voltage stays the same.
No, voltage across FG has to go up because
Voltage across the entire path.
Okay, fine, I'll accept that.
Smiley, if you just added that wire in,
Mhm.
were you saying before that conceptually
No.
it would stay the same
Wait.
because it can? Okay. So my stay the same thing wasn't that then.
No, it was a poorly timed explanation. Because when you do this, in reality, it will turn it off.
I'm a genius.
Okay, correct answer is
Get
A. So everybody good with that? Okay.
If one of the Walmart lanes gets robbed,
If one of the Walmart lines gets robbed, what?
you shoot the cashiers.
We bomb one of the Walmart lanes. You just run right through.
Stop working.
Tell your neighbor the correct answer.
C.
There we go, C.
Yeah.
Good job. Okay, this is just a summary of what we just went through.
Yeah, this is the same.
Same thing. Okay,
No, not entirely. You've changed which resistor you're getting rid of. You just
that's
forced it
true.
right.
That's true. Okay, so correct answer is see.
Oh, I misread D.
Okay. So here's our original circuit.
The last one was this one's the real one.
Oh.
This is
This.
no, this is
Oh.
I'll have this look right.
Thumbs up when you have a guess.
I don't have a guess. I have the answer.
Tell your neighbor your guess or your answer.
Isaac, if you got it wrong, you have to drop the class.
Think about it in reverse.
Correct answer is everybody good with that?
Isaac doesn't drop the class.
You want me to drop the class? But let's see, you're on my list of
Isaac,
evil
Isaac,
people. There's
Isaac,
two people
Isaac.
on the list.
Evil people.
Who's the other person?
Me.
No, that's the world's largest terrorist organization.
Nice.
In that order?
You're on an exclusive list, right?
Bro, I feel so special, okay?
Hitler.
I'm Harlan Ben Laden.
No. No, you got the wrong. You got the wrong.
All right, here we go. Come on, we're almost there.
One of the world's largest
That's why it takes so long for me to grade tests. All right,
Walmart.
here we go. Here we go. Come on. We're so close. I just want to finish this little snippet here.
I'll give you a hint. It's useless. Watch his Catherine's YouTube channel, but you don't know who Catherine is.
Have a conversation.
Because it said points A to B, unless it meant points A to E. Because I did that parallel and then.
So you just find the total resistance. Total resistance. Like pretend this is connected to the battery.
Okay, so it's not points A to B. It's point A to E.
No, A to B. So it's like here's the battery. You just find the total resistance.
Okay.
Well, I said B before.
Corey, you're ready for this athletic leadership meeting?
I don't know if it's torn.
I'm not.
Voltage, hang on. The voltage across DC is insane. Because of the loop rule. Resistance in DC is shoot.
I was gonna say C. I was gonna say C before.
No, so you have to think about the resistance. No,
I get
the
you.
resistance.
I feel like 90% of the people feel that way about the whole situation.
And like I'm not gonna miss class.
Am I crazy? No, I get you.
Okay, and we give a big hint. Ready? It's this question.
Oh. I mean, it's a me problem.
What was the answer?
Stay the same.
No, it doesn't stay the same. We'll pick it up tomorrow.
You think the test will be graded by tomorrow?
No.
Finally, what happened?
I said, watch his Catherine's YouTube
Cliffhanger.
channel. It's not the
No,
reason.
okay, easy.
I did.
All you have to do is like, you're a YouTuber. You're not know why you're
Hang
gay.
on, fine.